In this lesson, we are looking at an introduction to algebraic fractions. We look at the structure of the fraction, how to simplify them, then we'll work some examples. Take note, algebraic fractions are also known as rational expressions or rational functions. Without much ado, let's quickly look into it. So, talking of the structure of the algebraic fraction, if you know how a normal fraction looks like, then I think you know all about this. It has a numerator, the vinculum, and then the denominator. So just as we write a normal algebraic expression, that is a then over b. So this is your vinculum. The a can be an algebraic expression. The b can also be an algebraic expression. At least there should be one algebraic expression. Now, some examples can be 3x over 5. Then we have x plus 2 over 4. Then finally, 2x plus 1 all over x minus 3. Now, as you take note, all of these do have at least an algebraic expression, either at the numerator, the denominator, or both. So this is our algebraic expression over 5. This is also another algebraic expression over 5. For this particular one, both the numerator and then the denominator do have algebraic expressions. So it is just like an ordinary fraction, but then there are letters or variables. Now you have to take note, the denominator of an algebraic expression can never be 0. So you can never write a numerator over 0. No, we don't do that. Now that we know what the algebraic fractions are, let's look at how we can simplify them just as we simplify fractions. So when it comes to simplifying algebraic fractions, this is actually where we'll be applying the factorizations that we learned earlier in this playlist. So the first thing you need to do is to factorize the numerator and the denominator. You factorize what? The numerator and the denominator. That is, if there's room for factorization, you have to do that. After factorizing, you then cancel out the common factors. Now, there's a mistake that most students make. We don't cancel out terms, that is, those separated by addition and subtraction. We rather cancel out factors. So if the expressions are multiplying, that is when you cancel out. If they are adding or subtraction, if they are adding or subtracting, you don't cancel out. As we proceed, you will see some examples, and I hope it will be clarified. Let's take some examples. So in our first example here, we have 10x squared over 5x. So 10x squared over 5x. Now, how do we go about it? If you look at this, there's no factorization, you see. So they are all just 1 times each. Hence, to simplify, our 5 divides the 10 how many times? 2 times. And then we come to the x's. So x squared over x. Now we know we apply the laws of indices here, where you have 1 as the power of x, and then we have 2. And it says if we are dividing, what do? We subtract the exponent, so that we have x to the power 2 divided by what? X to the power 1, which gives us x to the power 1. You see, that is what this here is going to give us. Hence, we have 2, then x to the power 1 all over 1, because all of this will then cancel out. So we can choose to omit the denominator, which is 1. And we can also choose to ignore that 1 we have here. Hence, 10x squared over 5x becomes what? 2x. That is its simplification. This one is very, very simple. Let's take some that you would need to actually simplify or factorize. Now, in the second question, we are once again expected to simplify. So we have 4x, then plus 8 all over 4. Now, our first step says we should factorize. You see, this is what I meant by you not just canceling out. So that you look at it and then say, okay, I have 4, and then this 4 will cancel out this 4, giving me x plus 8. This is totally wrong. You can also not say the 4 divides itself once and then it divides 8 twice. Hence, we have 4x plus 2. This is also wrong. We don't cancel out if the terms are adding. We rather cancel out factors and not sums or differences. Hence, we need to factorize this we have over here. 4x plus 8 can be factorized as 4. So we know there is a 4 here, then there's a 4 here. That is the highest common factor of 4 and 8 is 4. Then into bracket, we have x, that is 4 times x, which gives us 4x. Then plus 4 times what gives us 8, that is a 2. Then all over 4. So it is this that we can now say we want to cancel out. Why? Because we have 4 times x plus 2 all over 4. The operation in between this is multiplication. So that is what allows us to say 4 is a factor of this expression, and x plus 2 is also a factor of this expression. So with that, we need to now do our cancellation. Cancelling, I have this 4, cancelling out this 4. And what do I have left? I have our x plus 2. As simple as that. So this becomes the simplified form of 4x plus 8 all over 4. Now take note, so far as you have a fair knowledge on algebra, when it comes to simplification of rational functions or algebraic fractions, they can test any of those knowledges, such as your knowledge on factorization of quadratic trinomials, and then your knowledge on difference of two squares. For instance, for this next question, it says x squared minus 9 over x plus 3. So this is actually testing your knowledge on difference of two squares. So we have x squared minus 9 all over x plus 3. Applying difference of two squares here, we know our x squared is like minus 9. It's actually x squared minus 3 squared. Then all over x plus 3. So x squared minus 3 squared gives us x minus 3, and then x plus 3, then all over x plus 3. I can take note that these are now factors. So x plus 3, and then x minus 3 all over x plus 3. Cancelling out, you can easily say this whole bracket cancels out this whole bracket. And with that, you are left with x minus 3. So this becomes your final answer after factorizing, after simplifying what you have over here. Once again, you can be asked to apply your knowledge on factorization. So as you see in this example, we have x plus 4 over x squared plus 6x plus 8. Now, the denominator here is now trinomial. It's a quadratic expression. We can only cancel if it is factorized. These are all sums, and then sometimes you might have differences. The x cannot straightforward come and then cancel this x, so that you say you then have your 4 over x squared plus 6 plus 8. No, that is wrong. So what do? We rather apply the method of factorization to factorize the denominator. And by so, I mean you have our x squared plus 6x, then plus 8. We've gone through how to factorize quadratic trinomials. You can always check that on the playlist. Hence, I wouldn't go into details here. 1 multiplies 8 to give us an 8. Then the factor pairs of 8, which when added gives us 6, is 4 and 2. So 4 times 2 gives us 8, and 4 plus 2 gives us 6. So instead of the 6, we can rewrite our expression as x squared plus 2x plus 4x, and then plus your 8. So with that, we can then say we group them in twos. So that x squared plus 2x comes in one bracket. Then in the other bracket, we have 4x plus 8. What does these two have in common? That is their highest common factor. That is an x. Then x squared divided by x gives us our x. And then 2x also divided by x gives us a positive 2. What is the highest common factor also of these? That is a positive 4. So 4x divided by 4 gives us an x. And then x also divided, 8 divided by 4 also gives us a 2. So with that, you realize that we have these two brackets that are similar. So we have x plus 2, then your x plus 4 also in one bracket. With this done, you now come all the way here, then do your necessary substitution. For our numerator, which remains the same, we have x plus 4. Then for our denominator, instead of x squared plus 4x plus 8, we come down here and then write all of this to substitute that. That is our x plus 2, then x plus 4. Now we can put our bracket here to indicate that it is all one term. So with that, we can then do our necessary cancellation. Since it's a product, this can be said to multiply 1. So since it is product, this can then cancel out this. How many times? Once. And with that, we are going to get a 1 over x plus 2 as our final answer. This is also another type where we are given what? A quadratic expression, which can either be at the denominator or the numerator. We'll end this lesson here, and I'll give you some exercises as usual, so you try on your own, test your understanding. So here are just 5 expressions that you have to try on your own to test your understanding. I do hope this lesson was helpful. If this is your first time on this channel and you think it will be of help to you, you can choose to subscribe if you so do, so that anytime I release any video, you'll be notified as well. See you in our next lesson, where we look at how we can add and subtract algebraic fractions. Bye for now and stay safe.